Hi, this is Tej Arora. I'm an AWS Certified Solutions Architect Associate. In the AWS Quick Learn series, I will cover AWS services and features in short videos. These videos will provide a quick 360-degree coverage of a service or feature. They are suitable for those preparing for an exam or an interview or just want to refresh their knowledge. In this video, I will discuss EBS, the Elastic Block Store. EBS provides the Elastic Block Storage service. In your home PCs, you have hard disk drives, and these hard disk drives are divided into partitions, and each partition is called a logical device. EBS volumes roughly correspond to these partitions. So in contrast with block storage, other types of storage services include the object storage service provided by S3, file storage provided by Elastic File Store, and the database storage provided by RDS and other database services. Now, EBS is primarily used as attachments to EC2 instances. EBS is suitable for a variety of applications. It provides high throughput at gigabytes per second and provides high I/O rates with small millisecond latency performance. So applications needing such throughput and latencies can use EBS. If the EBS service provides a variety of different types of volumes, which gives the user flexibility in choosing the right model for the application requirements and also help optimize costs. So what are the strengths of the EBS service? In terms of elasticity, it's possible to modify volumes dynamically. You can do things like increase volume sizes, tune the I/O operations per second capacity that's provisioned. You can change the volume type, and you can do all this with no downtime or impact on performance of the running application. Now, you can also do the dynamic modification programmatically by watching CloudWatch metrics and at appropriate thresholds, triggering a Lambda function to make the change. In terms of performance, EBS provides very high throughput storage options such as SSD, the solid state device. It provides dedicated bandwidth between EC2 instances and storage. This feature is referred to as EBS optimized instances. It provides the ability to restore a volume from a snapshot rapidly. This feature is called Fast Snapshot Restore, or FSR. And also the encryption that you can enable on volumes has no impact on performance. In addition to offerings by EBS, you can get additional performance by striping your data across multiple volumes, which is the RAID 0 style, to get increased throughput and I/O performance. You can get up to 80,000 IOPS per EC2 instance using this approach. EBS storage scales to petabytes. The availability is as high as 5 nines. EBS volumes are replicated within an availability zone. Now, the volume durability varies between 99.8 and 5 nines, and snapshot durability is 11 nines because snapshots are stored in S3. EBS allows you to take backups of your block store using snapshots and then copy it to other availability zones and regions, thus helping with disaster recovery in case there is a problem. As far as reliability is concerned, EBS volumes are 10 to 2000 times more reliable than commodity disk drives. These disk drives have an annual failure rate of 2%, whereas EBS volumes have an annual failure rate of 0.2 to 0.001%. In addition to that, applications can enhance reliability by adding redundancy through RAID 1. From a security perspective, one can encrypt volumes and snapshots at rest, and you can either use automatically generated keys or self-generated keys, both managed by the key management service. Now, between EC2 instances and EBS volume, the data that travels is encrypted as well because the encryption occurs at EC2 servers. So once the data gets on the wire from EC2 to the EBS devices, it's encrypted. And when it comes back, it's encrypted and then it's decrypted back at EC2. The use cases for EBS include mission-critical enterprise applications, mission-critical relational databases or NoSQL databases, big data analytics workloads. You can run Elastic file systems on top, and you can also use EBS for disaster recovery of block data using the snapshots and restore snapshots feature. There are multiple volume types with different performance characteristics. Let's take a quick look at these types. So there are 5 types of EBS volumes, broadly classified into 2 kinds, the solid state drives and the hard disk drives. The solid state drives provide high transactional throughput and also high durability. They also cost more. They have higher capacity, higher throughput. So let's take a look at some of the characteristics of solid state drives. The IO2 class has the highest durability and the highest performance of all the different types. It is also the most expensive. It is suitable for IO intensive mission critical databases. The IO1 is very similar except for the fact that it doesn't have durability as high as the IO2 class. The GP2 SSD class is good for interactive applications that need to have low latency. It's also good for boot volumes. Its IOPS are slightly lower than the IO1 and IO2 classes, and so is the maximum throughput, and it's slightly cheaper. The hard disk drive types include ST1 and SC1. ST1 is good for throughput intensive workloads such as processing of logs, big data processing, and data warehouses, which include a lot of sequential data processing. And the lowest class is the SC1. It's good for infrequently accessed data such as home directories of users. It's the cheapest. Now, if you look at performance characteristics, there is volume characteristics in terms of IOPS and throughput, and then there is instance characteristics in terms of IOPS and throughput. Now, note that you can attach multiple volumes to an instance. So the instance limits are higher than individual volume limits. So these are limits of a specific volume that you can get for each type. And these are the limits you can get on an EC2 instance. So if you look at IOPS, 160,000 IOPS, which is IO operations per second, can be achieved on one instance. And the maximum throughput that's achievable on an instance is 4,750 megabytes per second. Whereas at a volume level, the max IOPS you can get per volume is 64,000, going down all the way to 250 IO operations per second. And the maximum throughput you can get per volume is 1,000 megabytes per second, going down to 250 megabytes per second. Now let's look at some of the key resources and concepts in EBS. There's essentially 2 types of resources, volumes and snapshots. An EBS volume is of instance storage, that is, it's network attached storage. So these blocks of data live on devices that are in the network, accessed over the network from an EC2 instance. In contrast, instance store volumes reside on storage that is local to the host where the EC2 instance is run. We'll take a look at differences between EBS volumes and instance store volumes in a moment. A volume can be attached to or detached from an EC2 instance. The lifetime of a volume is independent of the lifetime of an EC2 instance, unless you set the delete on termination flag for EBS volumes to true on the EC2 instance, which means when the EC2 instance terminates, the EBS volumes also terminate. Once you attach an EBS volume to an EC2 instance, you can work with it as if it was a partition of a physical disk drive. Note that a volume can only be used within an availability zone, and it's replicated within that availability zone for reliability. A volume can be attached to one EC2 instance at a time, although there are some exceptions which I will cover in a few minutes. The types of volumes include boot volume and data volumes. An EC2 instance can have one boot volume and multiple data volumes, and either of these can be encrypted. Volumes can be backed up via the snapshot feature. A snapshot is essentially a point in time of the volume. And note that creation of a snapshot does not impact the performance or the availability of the volume while the snapshot is being produced. A volume can be reconstructed from a snapshot or restored from a snapshot, and a volume can be encrypted by default. In contrast, a snapshot is a backup copy of a volume. You can also take snapshots of non-EBS on-premises block storage in your own data centers. Snapshots are stored in S3, but note that they're not available via the S3 API. They are only available via the EC2 API. So note that a snapshot is a point-in-time copy of all the data that is written to the blocks in the volume, which means it does not include any writes to a volume that are cached in the OS and not physically written to the blocks in the volume. So it's recommended that you unmount a volume before taking a snapshot to get a consistent snap. If the volume happens to be a boot volume, then it's best to stop the instance before taking a snapshot of the boot volume. Creation of snapshots is asynchronous, which means while it's happening, you can be accessing the volume without impact on performance or functionality. The contents of a snapshot are not affected by ongoing writes to the volume. Now, when you take successive snapshots of a volume, each snapshot is a logically complete snapshot. But physically, it's only incremental data, which means the snapshot has only the blocks that changed after the previous snapshot and not all the blocks. A snapshot can be used only within a region where it is created, but it can be copied across regions and to different accounts. If the eventual purpose of a snapshot is to restore to an EBS volume, note that if a snapshot is encrypted, the restored volume is also encrypted. And when snapshot is restored to a volume, the volume is immediately accessible by the instance even before all the data is copied, because blocks are loaded to the volume lazily. So when you access a block for the very first time, there is a increased latency, but subsequent accesses to the block do not incur a latency. Now with the fast snapshot restore feature, the volume is instantly accessible at full performance. As compared to the case without FSR, volume is instantly accessible but not at full performance. When you restore a volume from a snapshot, you have the option of increasing the size of the volume, and you can also increase the size of the volume anytime after the restore as well. Now, when a snapshot can be encrypted, this happens automatically if the volume is encrypted, but you also have the option, if the volume is not encrypted, to encrypt the snapshot. Now, snapshot management can be automated using DLM, the Data Lifecycle Manager. DLM allows you to author policies to schedule the creation and deletion of snapshots, to share snapshot, and you can program retention periods. The Snapshots API can be used to create snapshots of non-EBS block data, such as block stores in on-premises data centers. It can also be used to read a snapshot directly without having to first convert it to a volume. This is useful for third-party backup applications. They can easily track changes to volumes using this and optimize their backup and restore solutions. Now, what can you do with snapshots? It helps with disaster recovery of block storage data. You can migrate data across availability zones and regions and accounts, and also helps in migrating data from on-premise to the cloud. And with the help of DLM policies, you can meet compliance requirements for data backups in an automated way. Note that when you delete a snapshot, it has no impact on the volume it was taken from. And if you delete a volume, it has no impact on all the snapshots that were taken from it. Their lifetimes are independent. Now let's take a quick look at the two kinds of volumes you can use with an EC2 instance: EBS volumes and instance store volumes. An EBS volume is network attached storage. Instance store volume is host local storage. By the way, instance store volumes are also known as ephemeral volumes, and you will quickly see why. Now, an EBS volume can exist before an EC2 instance is created, and it can persist after an instance stops or terminates. In other words, EBS volume lifecycle is independent of EC2 instance lifecycle. Whereas ephemeral volumes or instance store volumes, they're born along with an instance and they're gone when the instance stops or terminates. Except on reboots, they persist. So if a storage drive fails or an instance stops or terminates, the data on an instance store volume is lost forever. An EBS volume can be detached from one instance and attached to another. You cannot detach and reattach ephemeral volumes. So why then would one want to use ephemeral volumes? Since it is host local storage as opposed to network storage, they are 10 times faster for writes and 5 times faster for uncached reads. You can look up this link for more details. So then you would use these volumes for high throughput temporary storage. It's good for scratch space, caching, and for swap space. So if you want to build a storage cluster with redundancy where the application has fault tolerance, such as NoSQL clusters or file system clusters, then instant store volumes can work. They are also good for big data processing, which can be resumed or restarted on failure. It is also good for log processing, whereas EBS volumes are perfect for mission critical durable block store, such as transactional databases for a business. So when you create an AMI from an EC2 instance, all the EBS volumes attached are preserved in the AMI, but instant store volumes are not preserved in the. When you change the type of an EC2 instance, EBS volumes get reattached to the new type, but instant store volumes do not. The sizes range from 4 GB to 16 terabytes for EBS and 32 GB to 2.4 terabytes for instant store volumes. The root volume can be a max of 10 gigabytes. And finally, EBS volumes you can change on the fly, its size, the type, and the IOPS, whereas instant store volumes cannot be changed. Let's look at some of the key features of EBS. So FSR, fast snapshot restore, I had already alluded to that. What you need to do to use this feature is to enable FSR on a snapshot that you own or has been shared. Now, data lifecycle management for snapshots is a cool feature that helps you automate backups of EBS volumes into snapshots using policies. You can also have policy-based retention and deletion to save costs and to meet compliance regularly. And monitoring of activity on snapshots, you can look at CloudTrail. Now, EBS optimized instances is an EC2 feature, and what that does is between the EC2 instance and EBS, the network bandwidth is dedicated, and this dedicated bandwidth is separate from the other network traffic to and from the EC2 instance. There is a separate hourly charge for using an EBS optimized instance, in other words, for reserving bandwidth for EBS, and not all instance types support this feature. Multi-attach, typically an EBS volume can be attached to one EC2 instance at a time. However, IO1 and IO2 volume types can be attached to up to 16 Nitro-based EC2 instances. Each instance has full read-write access to the volume that is attached to all the instances. Now, the consistency of the data, as you can imagine, is up to the application. So this is suitable for situations where the application coordinates consistency. It can achieve high throughput via parallel reads and writes. That's the advantage. This is also suitable for read-only scenarios where multiple EC2 instances are reading the same volume at the same time. Multi-volume snapshots is a feature that allows you to take a point-in-time snapshot of the entire application workload, which includes potentially multiple volumes. And you can do this without stopping an instance. The snapshot of every volume that is part of this multi-volume snapshot is stored independently. For practical purposes, this set of snapshots is typically restored together. So it is recommended that you use tags to mark the members of the set. And note that the snapshot from every volume is from a single point in time. You can monitor volumes in two ways. There is a status check and a performance check. The status check on a volume runs automatically every 5 minutes. And if EBS detects some inconsistency in the data on the volume, it disables IO to the volume, as a result of which the next status check fails and an event is raised. However, if auto enable IO flag is set, the status check passes and IO is not disabled when EBS detects any inconsistency. And there is a performance check, and this happens only for IO1 and IO2 volume types, which are the highest performing volume types. And this happens every minute. However, CloudWatch collects the data every 5 minutes. Now, quotas related to EBS, there can be 100,000 snapshots per account. If you're copying snapshots to a region, specific region, the maximum concurrent copies is 20. And the number of snapshots that you can enable for fast restore is 50, and the total provision IOPS limit is 300,000 for IO2 and 100,000 for IO1. This is across all the volumes. The pricing factors for EBS include gigabyte months of actual storage, and price varies by the type, and IO2 is the most expensive class and SC1 is the least expensive. The other factor is provision IOPS month, and provision IOPS is supported only for IO1 and IO2. Then GB months of snapshot storage, which is stored in S3. And when you copy snapshots to other regions, there are data transfer charges. And when you enable FSR on a snapshot, there is a per hour charge for when it's enabled. It's referred to as DSU hours or data services unit hours. There are charges for snapshot API calls. The free tier gives you for 12 months from the time account is created, 30 GB storage, 2 million IOs, and 1 GB snapshot storage. Let's look at the EBS related CloudWatch metrics and events. So there's basic and detailed metrics. Basic metrics are collected at 5-minute intervals and they're free. They are metrics of the root volumes only. Detailed metrics are collected at 1-minute intervals for all IO1 and IO2 SSD volumes. The metrics that are collected include their volume metrics, and they include read-write operations, quantity of data read and written, the total read and write time, the time the volume is idle, the length of the queue of IO requests for the volume, and the percentage of throughput of the volume that is being utilized. Events are generated when volumes are created, deleted, or attached and detached, or when snapshots are created, copied, and shared and deleted. EBS is integrated with EC2. EC2 is the main way to use EBS volumes. It's also integrated with CloudWatch and CloudTrail and with IAM for authorization policies for control operations on the volumes and snapshots. Now, in terms of facilitating the 5 pillars of the well-architected framework, let's see what EBS does. CloudWatch metrics at the volume and instance level, they help monitor failures and performance problems with EBS, and it's possible to grow volumes automatically based on these metrics as demand increases. For security, EBS data can be encrypted at rest and it's encrypted in transit. The access to the volumes and snapshots is governed by IAM policies, and for extra safety, when an EBS volume is terminated, its blocks are overwritten with zeros so that data does not leak from one customer to another. For reliability, snapshots are a great feature to assist with disaster recovery plans, and volumes are replicated within an availability zone for high reliability. In other words, very low annual failure rates. For performance efficiency, when you create successive volume snapshots, they are incremental, which means there is less data to copy when a snapshot is created. And one can do volume level sizing with IOPS and instance level sizing using EBS optimized instances to optimize the price performance ratio. CloudWatch metrics at volume and instance levels, they help monitor and tune performance. For example, if you monitor the queue depth for a volume, you can see whether a volume is being utilized well or not. Now, in terms of cost optimization, successive volume snapshots are incremental. Therefore, it costs less to store them. And a variety of volume types are provided so that users can optimize their costs based on their requirements. And the trusted advisor, it shows underutilized volumes, which can help save costs. This completes the discussion on EBS. Thanks for watching the video. If you found it useful, please consider clicking on the like and subscribe buttons. If you can leave a comment about what you liked and what could improve, I would really appreciate that. Thanks again.